Good day, grade 7 learners. This is Super Mom Z, and welcome to Sci Amazing Learning Videos. In our last video, we described motion in terms of distance and displacement. For today's episode, we will talk about speed, velocity, and acceleration. Come on, let's start learning. Most essential learning competency. The learners should be able to describe motion in terms of speed, velocity, and acceleration. For sure, you have watched a car commercial before, or athletes in track, or weather forecast in your television the other day. All of this show motion. And how fast they are? That's what we're gonna find out. Speed refers to how fast an object is moving. In other words, how far an object moves in a given time interval, as depicted in the formula speed is equal to distance divided by time. Speed is usually denoted by the letter S or V, while distance and time are denoted by the letters D and T respectively. An object moving at high speed covers greater distance in a particular amount of time, while an object moving at a low speed covers less distance in the same amount of time. In this animation, which car is moving with the highest speed? Nice! The green car is the fastest, or the one moving with the highest speed. Speed is a scalar quantity, which means it only has a magnitude and no direction. Common units of speed include meters per second, kilometers per hour, and miles per hour. Now, when we talk about speed, there's what we call an average speed. Average speed is an object's speed all throughout its travel. Consider this example. The car has varying speeds throughout its journey. In this example, what is the car's speed at this instant? You got it. It is 1 meter per second. Now let's take a look at the speed of this car. What do you notice? Yes, its speed doesn't vary. In this case, the car has constant speed, which means the object has the same speed while traveling. Oh, have you seen this before? Where do you see this gauge? Correct. We see it in vehicles. Do you know what it's called? Right. This is a speedometer. It is a gauge that measures and displays the instantaneous speed of a vehicle. Are you familiar with the maximum speed limits in expressways? Cars and SUVs can run as fast as 100 kilometers per hour, while buses and public utility vehicles can only run as fast as 60 kilometers per hour. It is important to observe the speed limits to avoid accidents and collisions. Now, are you ready to apply what we have learned and solve some problems? Get your calculator now. Remember this triangle when solving speed problems. When we are looking for the distance, we just have to multiply speed and time. When we are looking for time, we just have to divide distance by speed. Lastly, if we want to find speed, just divide distance by time. Okay, are you ready now? Sample problem number 1. A truck travels 60 kilometers in 2 hours. What is the average speed of the truck? To solve this problem systematically, let us identify the GUFSA. Given, unknown, formula, solution, and answer. For the given, we have distance, 60 kilometers, and time, 2 hours. Unknown, what are we looking for in this problem? You got it. We are looking for the average speed. Next, formula. What formula are we going to use? Right, we are going to use speed is equal to distance divided by time. Now, let's solve it by substituting the given. Speed is equal to 60 kilometers divided by 2 hours. Divide them and what do you get? Perfect. The answer is 30 kilometers per hour. The average speed of the truck is 30 kilometers per hour. Fantastic. Let's try another one. Find the time taken by a car to complete the journey of 400 kilometers with an average speed of 50 kilometers per hour. For the given, we have distance 400 kilometers and speed 50 kilometers per hour. Unknown, what do we need to find? Nice, we need to find time. Formula. What formula are we going to use? Remember the formula triangle? Yes, we will use the formula for time. Time is equal to distance divided by speed. Next, let's substitute the given. Time is equal to 400 kilometers divided by 50 kilometers per hour. Divide them, cancel the unit kilometers, and what do we get? Yes, the answer is 8 hours. It took the car 8 hours to complete its journey. Good job, everyone. Look, a weather bulletin. Whenever there is a storm coming, we are notified of its impending danger in terms of its speed and direction. Aside from this, we are also informed about its strength. Do you know that as the storm moves, its winds move in circles? The circular speed of the winds of the storm determines its strength. On July of 2011, the storm Juaning entered the Philippine area of responsibility. When we describe speed with direction, we now refer to velocity. Velocity is the rate of change in displacement. It is a vector quantity, meaning it has a magnitude and direction. For example, 2 kilometers per hour east, 10 meters per second northeast, 4 miles per hour west. So basically, velocity is speed with direction. To solve for velocity, we use the formula velocity is equal to displacement divided by time. Notice the symbols that represent velocity, displacement, and time. Also, check out this formula triangle to guide us in problem solving. Okay, let's have another problem. What is a cyclist's average velocity if he changes position from 10 meters east to 40 meters east during 5 seconds interval? For the given, the initial position is 10 meters east. The final position is 40 meters east, and the time is 5 seconds. Unknown. We are looking for the average velocity. Formula. Using the formula triangle, we will use the formula velocity is equal to displacement divided by time. To get the displacement or the shortest distance traveled, we need to subtract the initial position from the final position, so that is 40 meters east minus 10 meters east all over 5 seconds. What will be our final answer now? Excellent. The answer is 6 meters per second east. The cyclist average velocity is 6 meters per second east. A sigh amazing clap for all of you. Finally, let us move on to acceleration. Acceleration is any change in speed or velocity. When there is an increase in speed or velocity, it is a positive acceleration. Otherwise, if there is a decrease or an object is slowing down, it is deceleration. When an object is in constant motion, like in this example, do you think there is acceleration? No, there is no acceleration if an object is moving at a constant speed in the same direction. Units for acceleration include meters per second squared and kilometers per hour squared. To solve for acceleration, we divide change in velocity by time. And to get the change in velocity, we will subtract the initial velocity from the final velocity. Are you ready to solve another problem? Okay. A fish swimming at a constant speed of 0.5 meters per second suddenly notices a shark behind it. 5 seconds later, the fish is swimming in the same direction at a speed of 2.5 meters per second. Calculate its acceleration. For the given, the initial velocity is 0.5 meters per second. The final velocity is 2.5 meters per second. The time is 5 seconds. Unknown. We are looking for the acceleration of the fish. Formula. Acceleration is equal to change in velocity divided by time. Solution. Acceleration is equal to 2.5 meters per second minus 0.5 meters per second all over 5 seconds. The answer is 0.4 meters per second squared. The acceleration of the fish is 0.4 meters per second squared, meaning it is a positive acceleration. Finally, keep in mind that if there is uniform motion in which the object travels equal distances at equal time, the object is not accelerating because the speed and direction do not change. Meanwhile, if there is non-uniform motion in which the object travels unequal distances at unequal time, the object is accelerating because the speed and direction change. And that's all for motion in terms of speed, velocity, and acceleration. I hope you understood their differences, the proper way to solve them, and their application in real life in this Amazing episode. See you again next time. Bye!